Alright, so now let's go ahead and practice taking the derivatives of these tangents. So we have the derivative of the outside and the derivative of the inside here. So the derivative of the outside, the derivative of tangent, is secant squared of whatever the heck is currently in there. Sorry, this pen is failing me a little bit. Let's switch over. Okay. Now, using the chain rule, I just took the derivative of the outside, which is that tangent function. So now I'm going to times it by the derivative of the inside, which is the t cubed plus 1. So times 3t squared. Now, I'm not going to leave it this way. I'm going to write it pretty for my final answer. So my final answer here will be 3t squared secant squared of t cubed plus 1. So remember, you always want to bring out any coefficients without pluses or minuses that are being multiplied by the trig function in front of the trig function. Alright, let's go ahead and do the next one. So in this case, this is interesting. What is the outside function here? Is it the tangent? In this case, it's not. It is the cubic function. Okay, let me kind of show you. If we rewrote this, this is the same thing as tangent of t to the third. So the outside function here is that cubic function, and the inside function is the tangent function. So first, let's start by taking the derivative of the outside. I have 3 times the inside squared times the derivative of the inside. The derivative of tangent of t is secant squared t. Alright, so to finish this off, I'm going to write it. I don't have anything I need to bring out in front, but this squared is not currently in the correct notation. 3 tangent squared t secant squared t. And I'm going to throw parentheses around these so that I'm not thinking that the secant is inside this tangent. It's clear what's inside what. Alrighty. Last thing, might as well touch on here. The graph of a tangent function has a bunch of asymptotes. This is due to the fact that tangent equals sine of t over cosine of t. Whenever cosine equals 0, I'm all of a sudden getting a divide by 0 scenario, which breaks the function and gives me a vertical asymptote. So you'll notice at negative pi halves, I have an asymptote. At pi halves, I have an asymptote. At 3 pi halves, I have an asymptote. And that's because at pi halves, my cosine value, the x value, is 0. At 3 pi halves, my x value is 0. So essentially, when I'm going around the unit circle here, as I hit these vertical lines, I'm getting an asymptote on my tangent function. So that is how that's working. Alright, so you only need to do the book assignment. You do not need to do the worksheet, obviously. There's no worksheet. So take a look at your calendar. If you've lost that calendar, I will also post it on Canvas with this assignment here, so you can see what your homework is. Alright, folks. Hope that worked out well for you. I am excited for this new online learning stuff. And make sure you check out the class discussion. Feel free to ask any homework questions. And I'm going to try and schedule a Zoom video conference with you all to kind of touch on any homework questions you have and answer any questions you have. So keep an eye out for that link and that schedule. Alright, see you later.